So, I mean, it's a lot of fun to be here. This is my first time at WikidataCon, and really thrilled to be here. And I'm going to talk today about the work that we have been doing on creating subsets of Wikidata. Creating subsets of Wikidata is hard because, how do I specify what I want? Do I specify what I want, or do I specify what I don't want? I want everything except, or both. And I don't want to say too much. I don't want to be too detailed because Wikidata is so large that I'm probably going to get it wrong. And then at the end, I want a coherent subgraph. I want, if I have a subgraph, I want to have all the classes and superclasses of the items that I have in my graph, the property definitions, the qualifiers, the references, the labels, the aliases, everything that's for my graph. And I don't want to have to say that I want that. So here's an example. Suppose I want a graph about movies and books. I want information about the people, organizations, and places involved in these movies and books. And so this graphic is, imagine this is all of Wikidata. And I have, the top classes for my items of interest in person, Q5, organization, place, and creative work. And then, what I want is everything that's below those classes, the subclasses and the instances of the classes that are in each of these trees. And then I want all the edges that connect all those items that are between the trees, which I put in darker blue. And then in pink, I put in the subclass hierarchy. So I want all the connections all the way to entity. And so the question is, how do I make that happen? So here's what I want to have as a result. I have my graph of persons, organizations, places, and creative works, and all the connections between them. And this is just an example. And just for reference, I can actually construct this subgraph on my laptop using all of Wikidata without using the Sparkle endpoint because that will time out. Now, suppose that after that I say, well, maybe I just want another subgraph of my subgraph about Arnold Schwarzenegger. So I want to know everything about Arnold Schwarzenegger that is in this subgraph, a new, smaller subgraph. So I want to start from Arnold and then go forward some number of hops to find what Arnold is connected to and then get everything. And up here are statistics of the graph that I actually construct, which is in a tutorial that we gave, and you can see how I built this down here. And then, I can browse my graph. We have a browser that can browse, our version of Wikidata, and you can see Arnold Schwarzenegger. There's a link there. You can try it out and browse the graph. Now, another example. Suppose I want to create a co-author subgraph. So I have all the papers in Wikidata. There's about 40 million of them. And the orange little circles are the authors. And I want to create a co-author graph. So I want edges between authors if they co-author the paper. And I want a qualifier with the count of how many papers they co-author. And this is an interesting example because it's not strictly a subgraph, because this co-author relation doesn't actually exist in Wikidata. So the way that we do this is with a toolkit that we built called KGTK. It's the Graph Knowledge Toolkit, and it provides rich support to working with any KG, any knowledge graph, but we have worked almost exclusively with Wikidata, and we have done tons of things with it. And you can check out the toolkit there. And so, we've run a bunch of experiments comparing our KGTK toolkit to the Sparkle endpoint. And so, for instance, here is author network. If I run KGTK on my laptop, downloading all of Wikidata onto my laptop, I can compute the author network in 61 minutes. And by comparison, on the public Sparkle endpoint, it always times out. And we have a clone of Wikidata on a server. And even after 24 hours, the Sparkle endpoint had not computed the author network. So KGTK is very scalable for this kind of thing. And it runs on your laptop. So here's the query that creates the author subgraph. And we use a language similar to Cypher, Neo4j. So it's not Sparkle. And you just sort of specify what you want. I want a publication that's an instance of a class. That class has to be a subclass of Q591041, which is scientific publication. From the publication, I extract two variables for the author. I put a where clause that the one author has to be different from the other ones. I use greater than so that I don't get duplicates. And then I return the data. And so here's the data that I get. This author is co-author of this author on 396 publications and so on. And this will run in 1 hour. So summary, with KGTK, we can create really sophisticated subgraphs of Wikidata, and I can just do it by sort of mentioning the classes that I want, and it will, I can sort of get everything else, not for free, but very easily, and get a coherent graph. And, it'll run faster on your laptop than Sparkle on a server. And, just a plug for KGTK, it can do much more than subgraphs. You can do profiling of many kinds of all of Wikidata. We have scripts that will check all the constraints of properties, and we'll do that at about 1 or 2 minutes per property, network analytics, embeddings, and so on. And we have a tutorial of KGTK on Google Colab, so you can run it without installing anything. So let me stop sharing and just go to the browser. 1 second. I think I still have a minute. So this is the Arnold Schwarzenegger graph that I was talking about. And it's pretty cool. I mean, I can sort of, see, it looks like I have all of Wikidata here, but I only have less than 1%. And I can go, to the Maria Shriver, and there's Maria Shriver and so on. And if I go to things like classes, like author, one of the things that KGTK adds for you is this properties for this type. So there is properties for this type in Wikidata given by the editors. This one is computed from the actual data. So in my subgraph, I can see what properties are defined for people who are actors. So I can see that, award received is defined for 494 of them, and so on. So all the properties that are used in people who have occupation, actor, or any subclass of actor. And if I go to one of the relations like academic degree, then I can also see what classes academic degree is defined on. And so even after I define my subgraph, I kind of get all this stuff for free to sort of work with my subgraph. So, that is kind of the demo. You can sort of check out our page on the tools to create subgraphs using KGTK. So, 10 minutes, I can, be ready for questions if you have any questions.
There's one question in the chat. Renat is asking, why is it faster than BlazeGraph? Where's the magic happening in your system?
Okay. So, I mean, there are several reasons. So BlazeGraph does reification to represent the qualifiers. And in KGTK, we have a straight property graph representation. So the KGTK version of the data is much, much smaller than BlazeGraph. And, we also have optimizations for, we have an index for P279 star. It's translating the Cypher queries into SQL, and it uses an SQLite database to drive everything. And, it is, in many cases, more than 10 times faster. And, I think it's, the BlazeGraph is just not so great. Let's see. How is it handling properties that point to items that are not part of the subgraph? Are they removed or are they mapped to Wikidata? Okay, so that's a good question. So what happens at the edges of the graph? And so what it does is when you hit an item that is at the edge of the subgraph, we get all the properties that are not Wiki-based item properties. So the external identifiers, quantities, time, and so on. But we do get the P31 and the P279 and the transitive closure of those. So that when you get to the fringes, you still get something. So let me go back here and keep clicking. If I keep clicking, I will get to the fringes. And when I get to the fringes, I'm not able to. That's kind of the interesting thing about the way it's built. It's difficult to actually get to the fringes. Maybe if I think Meryl Streep is not well represented. So you see what happens at the fringes. So Meryl Streep, then we just say, it's an instance of human, and we get the page rank and not much else. Ismael Daniel Garijo told me you can download all of Wikidata in order to use. Yes, so you can download our KGTK format of Wikidata from our Google Drive. I will add that to the slides before I submit them. I know, any more questions?
Thank you. Thanks so much. Thank everyone.
Refresh the KGTK data set every 2 weeks. We're not quite there yet, but that's the plan, so that you can sort of download every 2 weeks, so it'll just be 2 weeks old